Alright, so for video 4, for lesson 3.3, we're going to start with the model for exponential growth or decay. And it states that for k is greater than 0, you have an exponential growth formula. So a of t is equal to a sub 0 times e raised to the kt. And for exponential decay, we have a of t is equal to a sub 0 times e raised to the negative kt. Remember, a of t is the amount at time t. A sub 0 is a of 0, which is the initial amount, which is when time is t is 0. K will be our relative rate of growth when it's greater than 0, or decay when it's less than 0, and t is going to be our time. Okay, and it also gives us the half-life formula. Remember, the half-life of any quantity whose value decreases with time is the time required for the quantity to decay to half of its initial value. The half-life h of a substance undergoing exponential decay at a rate of k, where k is going to be less than 0 because it's decaying, is given by this formula here. The half-life will be equal to the negative natural log of 2 divided by k. Alright, so let's look at some of this then, and we're going to move on to example 5. Alright, so in example 5, we're going to find the half-life of a substance. And so I'm going to have to read through it. Really, again, I'm going to advise you to print out the student notes here so that you can see it, or at least if you have a way to pull them up while you're able to listen to the video or see the video as well, definitely advise you to do that. Alright, so in example 5, it says, in an experiment, 18 grams of the radioactive element sodium-24 decayed to 6 grams in 24 hours. Finds its half-life to the nearest hour. Well, the first thing is we know, before we find the half-life, we just know that it's decreasing. So let's use our, which means it's decaying. So let's use our exponential growth, decay model. Alright, so we know that we're going to end up using a of t is equal to a sub 0 e, and I'm just going to put kt, because we're going to see that when we list everything that we know everything but k. And this way, if it is decay, which we know it is, but if it's decay, my answer should be, when I solve for k, my answer will be negative. Sorry about that. Got a little tongue-tied. Alright, so going back through the problem here, it says, in an experiment, 18 grams of the radioactive element sodium-24 decayed to. So 18 grams is our initial amount. So that's going to be my a sub 0. It decayed to 6 grams in 24 hours. So that a of t is going to be the 6 grams, and that happened in time t, which is 24 hours. So you can see there, the only variable we don't know is k. And so we're going to have to use this formula to find k, and then we'll go find the half-life. Alright, so plugging in what we do know, we know that a of t is 6 equals our initial amount of 18 times e, we don't know k, and t is 24. So just like we did in 3.2, we need to get that k is in the exponent, so we're going to get the exponential part by itself. So let's divide by the 18. And so I get 1/3 equals e, and k times 24 is just 24k. Well, I'm going to switch that around, so e to the 24k equals 1/3. And so this is in our b to the y equals x. So we know our base is e, our y is 24k, and our x is 1/3. And so we're going to change it, because we're in exponential form, we're going to change the log. So we got log base e of our x equals y, which is our 24k. So we got the natural log of 1/3 equals 24k, because remember log base e is natural log, divide by the 24. And so we know that k is going to be equal to the natural log of 1/3 over 24. And we can put that in our calculator and round it, but we're going to get a more exact answer if we don't. So it's up to you. Alright, so now that we know what k is, we can go find that half-life, because remember the half-life formula, they told us our half-life, let me see, I was trying to line it up there, is equal to negative natural log of 2 divided by k. And so now that we know what k is, we can plug in. So h is equal to negative natural log of 2 divided by the natural log of 1/3 divided by, what was it, 24? Well then, remember when you're dividing with fractions, you multiply by the reciprocal, or keep it, change it, flip it. So we know h is equal to negative natural log of 2 times, I'm going to write that kind of on top instead of in the middle there, the negative natural log of 2 times, because we change it, and then multiply by the reciprocal, so 24 over the natural log of 1/3. Now I think if you look in the teacher notes, they don't write as natural log of 1/3, but that's okay, we get the same answer. And so when I multiply straight across, I have negative 24 natural log of 2 divided by the natural log of 1/3. And when we put this in our calculator, we should find that h is equal to approximately 15 hours. Which means that 15 hours would be our half-life.